You are ready to start.
We can start.
Okay, 3, 2, 1, start.
Hello, welcome to our demo. The demo will be about cognitive and autonomous telco, where we will be showcasing customer intent, how it will be turning to network action. My name is Anıl Sönmez. I'm Principal Solution Architect in TME. I'm based on Dubai.
And my name is Szabolcs Molnar, aka Molnar. I'm an associate principal architect from the enterprise business unit, also out of Dubai.
Thanks. Now we will start with the demo itself, and after that we will be talking about architecture itself. Today here, I will be representing a gamer. I like to play online games, and today I have just purchased 5G router, and because I like mobility, I like to play anywhere. So I set up my 5G router. I started playing games, but as you can see also in the screen, I'm having some latency problems. As you can see here, there are some latency. Also, there are some packet losses. So I cannot really play a game because of the latency. That was something not expected. It is quite slow. So I'm an advanced user, so I have some telco backgrounds. I know that my connectivity is towards the 5G router, and after that it is connected to the G node B, and it is communicating with the 5G. So this is not expected. That's the reason I have decided to raise a ticket at the customer portal. So now I'm in front of the portal. It's automatically detected my IMSI number. Let me put my name. Say contact info. Now let's describe my issue here. I'm playing game. However, high latency affecting me during gameplay. Okay, sorry to hear you're experiencing. Can you tell me a bit more about the issue? What type of game? Let's mention this is online game, and I'm using wireless connectivity. How long have you been? Since I got my router and affecting all online games. Okay, my ticket has been opened. Now I think it is ready to be taken care by the vendor, by the 5G company that is serving this service to me.
Yes, so I will be actually assuming the role of the support operations of this service company. So I logged on to my simplistic chatbot application where I will be able to interact with my system. And for the sake of simplicity, I will simply be doing some commands as part of the demonstration. A couple of things to actually explain about this tool itself. So it is going to be connecting into our backend environment where we will have different types of systems integrated into the flow. During the architectural discussions, we will explaining all these sorts of things. So let me start off by asking the system to show me any open tickets in the environment. So the first open ticket came back with a low priority. The IMSI number is basically provided as part of the ticket that Anil actually opened not long ago, and a problem statement, right? It's a game streaming type of a ticket with some network-related, latency-related complaints. We see that it's an online game in the environment. So what I would like to actually do as a support operations perhaps is to look at the configuration of the subscriber itself. As you will see, based on the ticket that has been opened in this particular session, we will be at least attempting to try to get some further information about this specific configuration. So without providing actually an IMSI number, the system sort of went ahead and looked at the configurations, and immediately it came back with some sort of a resolution or suggestions based on an observed configuration element. So in this case, Anil's subscriber profile had a QoS index of 9, which based on the industry means it's a low priority sort of a channel where higher latencies are normal to assume. So the system is basically suggesting us that we increase this QoS to a higher priority. So that would be either a number 2 or a number 5 index. Let's attempt a number 2 index in this particular case. I'll instruct the system to actually update the same IMSI with that particular information. Anil, do you want to take over and showcase your screen?
Yes, exactly. Thank you. As exactly whenever you have changed, as you can see that the latency has gone. The network is excellent, as also you can see the latency drops and packet loss also gone. So simply my ticket and my configuration is sorted out. If we want to talk about architecture, I think you can take over, Molnar.
Yes, absolutely. So thank you for that. So from an architectural discussion perspective, what we will do is, what we will be actually showcasing is an explanation, if you will, about what has gone into this demo creation. So as you would imagine, we are running everything on OpenShift as our centralized platform. We are having an OpenShift AI deployment in the environment that will also be having a Llama Stack configuration, which is actually part of the OpenShift AI version 3.0 stack. The Llama Stack component itself has capabilities to basically provide a single unified API on the front-end side, maybe on the northbound side, and then provide integration points with different types of inference providers like LLM providers, and different types of integration components like MCP servers. And that's exactly what we have done in this particular case. As part of this demo, we have also provided a fine-tuned model. The base model or foundational model that we used was a Qwen-based large language model. And as part of the InstructLab fine-tuning activities, we have trained it with some intent classification capabilities, and we have provided some additional knowledge into the existing model itself. The resulting model is then actually served from a VLLM inference server. And we are using Granite Guardian models for guardrails, basically ensuring that our interaction with customers or customers is kept at an appropriate level. The overall applications and overall communications are happening through these bespoke chatbot components. We basically created two custom agents, one for the customer flow and another one for the support role as a support agent. Both of them are, of course, integrating with the APIs exposed by the Llama Stack running on top of OpenShift. And as an interaction, the MCP servers basically connect the different major and support components in this demo. One is an actual really operational 5G core based on Open5Gs, running, of course, on OpenShift. So we have an MCP capability to basically query, as an example, the subscriber database, as well as do some modifications and tweaks on some of the configurations of that of those components. Then we have an OpenShift connecting MCP that can basically provide Kubernetes specific information, pod status, and such related things. We have an Ansible automation platform integration as well in place, where we can do additional diagnostics and arbitrary automation jobs to do remediation, to do, again, triaging and whatever else might be required. And lastly, we have a ticketing system integrated into the mix. That's what you have actually seen when Anil opened the support case through the customer agent, the customer chatbot. Now, all this integration, as we discussed, as you have seen, is natural language sort of communications, and the Llama Stack, along with the large language models, basically identify and try to figure out what sort of activities you might want to actually do. And one of these directions, these activities could be, for example, a tool call. Now, these tool calls are through the MCP servers that are integrated into the Llama Stack as a configuration element in the mix. So as you have seen, the customer, Anil, basically started communicating with the chatbot. He provided his summary of the experiences, the complaints he had. Eventually, the model collected enough information to judge that it can open a ticket. The ticket itself was categorized as a network type a complaint based on the communication, based on the problem definitions. So there we use the intent classification to identify which components, what sort of products perhaps would be affected. And then the network support agent started basically working on the actual activities. Now, of course, this is a demo. There are much more complex use cases that we can basically take up, but I think we were able to demonstrate the simplistic, in a simplistic manner, the complex interactions between different systems, between different flows in the environment. I don't know, Anil, do you want to add anything to this discussion? Or
thank you. Actually, this demo can be extended into multiple technologies. What I mean is we will be able to show also Ansible integration, but we don't want to take time with that one. Also the same, we can fix some issues. Actually, we have done such kind of write-ups before, even some demos around how to fix the 5G environment. So these are the things we can add to demo, but we just want to make it a little bit more easy to digest. That's the reason we selected these flow. But depending on the requirement or if there is any ask, we can extend that one actually. Behind the scenes also, there are a lot of things working, like, for example, fine-tuning activity. We use Training Hub, which is based on RHEL AI or OpenShift AI coming via Instruct Lab. Actually, it is by itself is a long story that we can talk about that one, because actually this is a customer data that we get from the customer for fine-tuning the base model. This is something also we done, but we don't want to talk about much details in this flow actually. Back to you, Molnar.
Yes, thank you. So just to showcase, again, not too much detail here, but to actually show that that 5G core system is actually a running system in the background. So we have an Open5GS-based deployment where we have most of the components running. Of course, the Gnode Bs and the UPFs. And we also have presented a couple of blogs about automating such deployments and demonstrating actual network packets flowing through the system as a maybe a point of interest at the end of to tie off this whole topic. So thank you very much for your time. So this was the cognitive and autonomous telco demonstration by Anil and Molnar. Thank you very much.
Thank you.